Okay, so we're looking into the crankcase here. Sorry, the camera ran out of memory. So I'm on the phone again. But here's what we've got inside. And I think that's showing up pretty good. I'll try and shade that from the lights here. But I'm not seeing anything catastrophic yet. But we're going to keep tearing it down and keep going. This is a centrifugal unloader, and this allows the compressor not to be under a load when it starts, so you don't trip the breaker. We'll continue here. We'll come back when I got a little bit more torn down, maybe have the jug off. Okay, what I've decided to do here is an old mechanics trick, and I'm using the old broken ring to clean this groove out, and trying to just run it through there until I get this to run freely in here and not hang up. Kind of difficult to do while I'm holding the phone, but you know, you can kind of set it in here and see, like, that's not going in very well. You know, that's going to hang up. These have got to be able to rotate freely, just like this oil ring's doing. And if it's not going to do that, that's going to cause this to happen again. And this may be the reason they opened it up to begin with. I don't know, but I don't like it. I think this piston is still serviceable, even though it looks bad. You know, this shouldn't be touching the cylinder wall. We can maybe smooth that out a little bit with some sandpaper gently. I don't want to mess up the weighting on this too badly. But I think that if we can get these ring grooves cleaned out, and untie my tongue, then it should be okay. I mean, I can't really quantify how deep those are, you know, but I can tell you one thing. If this piston is collapsed right here, I'm not using it. So I need to contact Pacific Air Compressors or SAYLOR BEALL or somebody and see how much this low pressure piston is going to cost. If it's like $50 or something, I'll just pop on it and get a new one coming. It's not worth messing with. And low pressure piston looks really good, or excuse me, high pressure. So you can see in there, rings are free, and that's probably why we had 150 psi, even with this low pressure piston doing what it's doing. But I need to inspect these rods as well and make sure we haven't got any cracks or anything in them. And one thing I don't like is these newer rods. After, I think, 1980, they went to a cast aluminum instead of cast iron. I don't know why SAYLOR BEALL did that, but not a fan. So far, this is cleaning out decent. It feels about the same all the way across now. So I'm going to go ahead and slip that ring in there. And we'll just, yeah, see, that's pretty free where I've cleaned it. It's getting a little hung up over there, but we'll make sure that that's clean and that it's free before we try and put this back into service. Our main thing is we got new rings in here that aren't stuck. I mean, this is 100% of the problem. And also that these ring grooves are carbon free and clean. And we'll be pulling this piston out, and I'll clean this with brake cleaner and stuff and make sure everything's really righteous in here. What I did, I didn't tell you, what I did to get that other ring out, of course after it was broken, is I just got a screwdriver and gently tapped it around. And you want to wear safety glasses if you're going to do that, because these cast iron rings are really easy to break. And when I reinstall this, I'll be using a ring installer. And there's a special procedure to the oil rings. This one's a one piece, so you pretty much can just slip it over. Some of them allow you to spiral them on, and some say don't. So this one, I would say don't, because it's a solid. But some of them have a little corrugated piece in there. And then you have your two wipers, which I think is how that tune-up kit is. I think it's got a different style of oil control ring here. So you got oil control, compression, compression, compression. And the same thing here. Oil control, compression, compression, compression. When you're doing your rings, you've got generally an upside and a downside. Some of them have a dot, some of them have a bevel. Some of them don't matter, but you want to be careful of that before you install it so you don't get your rings upside down. And then of course clock them so that these grooves are, they say 90 degrees from each other. So if you've got 3 rings, you like one here, one there, you know, like the flux capacitor, something like that, something of that nature. So anyhow, crank is nice and free when I'm rotating it here. It's really, really nice. It's smooth, so I don't suspect we're going to find too much damage down on that crank. I'm hoping not. I don't want to have this crank turned. All right, we got the top of the piston decarboned. I do not see a mark indicating which side is the front, but we did get some numbers off of it here, so looks like a AE SB Sailor BEAL, I'm sure, 4047. So we'll look those numbers up, and then I got all but one of these rings. Oh, excuse me, I got all those rings out, the compression rings, but I haven't taken out the oil control ring yet. So we'll do that. Maybe if I'm really lucky, my assistant here will film for me.
I'm not an assistant.
The old Growly Bear.
Daddy!
Come on, Growly Bear.
Not Growly Bear.
And don't drop the camera, please.
I won't.
You won't?
No, I won't.
Okay. I'll believe you this time.
Hey.
Hay is for horses.
Mm.
Okay. I'm having a difficult time getting this. Let's try this way. Let's do this. No, you know what? Can we do it? Yeah. Okay, that was easier. Let's do it by hand. So, I'd like to try and clean this piston up a little bit. And then these grooves in here I'd like to clean. Need to get our snap rings out and pull this piston and the pin. I don't like the play I'm seeing in the end of that though. That one's got a lot of play in it too. I don't know if they gave me another set of bushings in there or if you just got to get new rods.
Whoa.
Out bowling the china shop, bowling the china shop. Okay, what I've decided to do here is an old mechanic's trick, and I'm using the old broken ring to clean this groove out, and trying to just run it through there until I get this to run freely in here and not hang up. It's kind of difficult to do while I'm holding the phone, but you know, you can kind of set it in here and see like that's not going in very well. You know, that's going to hang up. These have got to be able to rotate freely just like this oil ring's doing. And if it's not going to do that, that's going to cause this to happen again. And this may be the reason they opened it up to begin with. I don't know, but I don't like it. I think this piston is still serviceable, even though it looks bad. You know, this shouldn't be touching the cylinder wall. We can maybe smooth that out a little bit with some sandpaper gently, but I think that if we can get these ring grooves cleaned out, and untie my tongue, then it should be okay. I mean, I can't really quantify how deep those are, you know, but I can tell you one thing: if this piston is collapsed right here, I'm not using it. So I need to contact Pacific Air Compressors or Sailor BEALL or somebody and see how much this low pressure piston is going to cost. If it's like $50 or something, I'll just pop on it and get a new one coming. It's not worth messing with. And low pressure piston looks really good, or excuse me, high pressure. So you can see in there, rings are free, and that's probably why we had 150 psi, even with this low pressure piston doing what it's doing. But so far, this is cleaning out decent. It feels about the same all the way across now. So I'm going to go ahead and slip that ring in there, and we'll just, yeah, see, that's pretty free where I've cleaned it. It's getting a little hung up over there, but we'll make sure that that's clean. and that it's free before we try and put this back into service. And like I say, the piston looks scuffed and ugly, but I don't think that's going to be an issue because you really shouldn't be touching the skirt anyway. Only spot it's supposed to be contacting is the rings under normal circumstances.
I'm unzooming.
Okay, and then put it in your magnetic parts container. Now, the chair would quit sticking in my butt here. That would really help. I don't know. This doesn't.
From my view, I am the camera.
Alright, I can feel that wants to press out. I'm just wondering if I can stick this little screwdriver. I hate to let that clunk against that bearing.
That's loud.
So this isn't the right tool for this.
Hope you don't break the screwdriver.
For the screwdriver, I just don't want to damage the connecting rod. It's just a light press fit. That's all it is. Now, I need to drive it in a little further.
Gosh, it's cold.
I could get the screwdriver out of there. See, this is plastic though, so I'm not damaging the connection rod as long as only the plastic part's touching it. I can't get the screwdriver to come out. Okay, what we've got inside here is not a plain bearing. It's a needle roller bearing, so we should have new ones in the kit.
I'm zooming in. What's wrong?
That was pinning it in. Alright, so this is the inside of that. And let's push this back through and just check and see that there's not any.
Whew, man.
Not any wear on that. If you'll take your fingernail and run it across, I feel just ever so slight of a ridge right there. I'll bet that's less than a 10,000th. If you take a rag and wipe that clean. Now mind you, I'm going to be cleaning all this stuff later too, so normally you don't want to touch that kind of surface or plain bearings or baveted bearings or anything like that with your bare fingers, because the acid on your finger gets in there and it's not good for it. But you can see where it's been riding, but there's a little wear pattern there. But these bearings in here, if you want to come in here, these are a needle roller bearing. It's just like a dirt bike. Motorcycles use these. So it's set up like a dirt bike. A lot of car engines, you'll have a plain bearing in here that you're reamed to size. Give you a few thousandths of clearance. So that's how you take these apart. Low pressure side, I'm not going to bore you with that. It's the exact same. I am going to try and clean this piston up a little bit. I'd like to reuse it, and I think it's okay. This looks worse than it is, I'm sure, and as long as we're not contacting this and we're not hanging our rings up in here, I think we're okay. And this being an aluminum piston, it's rolled up that cylinder just a little bit. But let me see if I can pick this up and show you. But honestly, it's not too bad. I think that'll clean up with a hone. I can run my finger in there, and on camera I'm sure that's going to look horrible. But I can barely feel that in there. Like really, I can't even hardly catch my fingernail on that. So just a light honing in both of those cylinders. And this wear in here, I don't know if you can see on there, but that should be fine. I don't want to take too much out, but it should be okay. But everything so far is looking serviceable. I can guarantee you 100% that the reason that this air compressor pump is not working correctly was because of those piston rings on that side being seized, and that's from somebody not taking care of this and not running it with oil. And that has been evident throughout this entire build or disassembly. You can see the results of it here. This will happen in a car engine too. Another thing you got to remember is you better get your connecting rod caps back on the same piston and the same connecting rod, and also make sure they're facing the correct way. Some of them you can put it just backwards, 180 out, and you'll ruin your engine. I've seen 2 Jeep motors in the last year that threw a rod because of that. And one of them threw the rod right through the side of the block. So you need to be careful when you're doing this stuff. You can see the scuffing on these rings here. That's really bad. And as a result, it broke it. So we will use these as a tool to clean out these grooves. And when I get this all cleaned up, I'll show you the results and how it looks. This is how you do it. If you look real careful right there, you can see those shavings. Now that's where that piston has been kind of rolled over into the grooves. It's rolled that land into the groove, and that is a bad thing. So we're just going to lightly sand those and see if we can get them cleaned up. Maybe run a file across the edge of that and deburr it. Let's see how tight that ring is in there. That's nice, it's nice. Oh, no, now it's stuck. And that's right where the galling is. Lack of oil, fellers. Lack of oil. But this is probably in a shop somewhere and probably in a back room. They didn't give a crap about the compressor as long as it turned on, you know. They didn't notice a decrease in performance or anything. And this is an industrial compressor. But for my little shop, you know, I've got to have El Monstro running, and I depend on that every day. So I try and take care of my equipment. That's why I'm going to paint this too. So that's all for now. I'll get back at you when I've got this all cleaned up and show you how it turned out.
Should I pause it?
Yeah.
Okay. Ready, set.
Right now, and see in that trouble area
Dad?
what we've got to do.
So like the stupid camera went like to photo and it like
So put it back on video.
I did.
Are you videoing now?
Yes.
Okay, now we have to edit all this out.
Mm.
Okay, so I'm just checking here to see how these rings feel in here. I don't like it very much. I think they can be worked with. I mean, it's not terrible, but it could be better. So I'm comparing the side that's not all screwed up here to where I roll these around and we get into this area that was damaged. This is splash lubricated. I think there's a flipper on one of these connecting rods, probably on the low pressure side, and that's what the bearings in the bottom are going to get lubricated with, your piston skirt and that kind of stuff. But as I run it through there, I'm able to clean that and get rid of that burr that's been rolled over. And you get the shivers?
It's cold.
Yeah, well, it is in a cold state.
What else can I do?
Deep freeze state.
I thought this place was a desert.
It is a desert.
Why is it so cold then?
Well, the desert gets cold at night.
I know, but... Wait,
So we just want to keep working with this.
how come there's no sand if it's a desert?
There is sand.
What do you
Haven't you ever heard of Little Sahara?
mean? Nope.
Well, you're young yet.
What does that mean?
Means you haven't seen nothing. You haven't been nowhere. You haven't done anything. Okay, see, I'm still kind of getting caught right there. I can feel it dragging. So what I'll probably do is take a diamond file and just dress the edge of that so it's got a little bit of a radius or chamfer or whatever you want to call it. Bevel. But what we want to make sure of, and we want to make dang sure of, is that these rings are absolutely free to rotate so that they don't get hung up like that again. Because if that gets stuck in that groove again, just like that, we'll have the same situation. So I'll get this cleaned up and we'll come back when we've got this all cleaned and got all this gunk out of here. Got the Little piston cleaned up with brake fluid. Got all this burr cleaned out of here and everything. I just want to make really sure that if we're going to reuse this piston, that we don't have an issue later, and I just waste what was it, $204? What are you doing? Filming up my nose?
No, I just.
I'm gonna have to edit that out. Oh my god, giggles.
What out?
This is Giggles the Clown here.
Hey!
So, if you wonder who did the camera work on this, it's Giggles the Clown. Alrighty. Well, this feels a little bit better going through these grooves. I still feel I can catch that ring right about here on this one.
My knee is touching your knee and my foot is touching your foot.
Okay, thanks for that valuable piece of information. We'll store that away. Okay, what I'm trying to do is just take the little edge off there, the burr. I'm only in this damaged area. I don't want to widen out these grooves. Okay, let's try one more thing and then we're going to call it a night here in the old shoppy shop. So what, I'm feeling resistance right here. I think that's just the edge of this sharp ring digging in. Now, I've got this to the point where it feels good. It's clean. We've got this ring able to slide in there very easily. We didn't remove any material. We just cleaned up the edge of that. So I think we've got a problem solved. And let's just see what happens. Get that ring in there. I don't know if that's the ring that goes this groove. It was in there before, so. Still got a tight spot. Yeah, right there is a tight spot, which is funny because that's beyond where it was damaged. It might have got hot there or something.
Maybe.
So I'm going to clean this off with some brake cleaner, and then we'll try this again. So this is going to be cold, cold.
It is cold outside.
Okay, so I just got done calibrating the gauge. You can see here, this is kind of a cool gauge. Got a little sled here, and this will measure up to a 6-inch bore, all the way from 2 to 6 inches. Pretty nice little gauge made by Ames. Ancient, but still seems to work well. It's accurate down to 1/1000th of an inch. So what we're going to do is put that in the cylinder here. And this looks terrible on camera, but honestly, you can't even catch your finger on those little bits that look scuffed, you know, those sections that look scuffed. Let's go ahead and throw that gauge in the bore. I've already measured this once, but I'm going to try and do it again on camera. What I was getting was about 1/1000th at the widest point, which is of course at the top. Now we're down in the cylinder just below the ridge. I'm getting just over 1/1000th. As we slide that down in the bore, it actually reads just a touch undersized, maybe 1/10. It's hard to say. I'm trying to keep that sled against that wall. It's kind of hard because I'm at a weird angle. But we can rotate this to the other side. I like to kind of move that up and down so that we make sure that sled is contacting. And I'm getting 1/1000th undersized. Okay, I go down a little bit further. I think that sled just isn't contacting that cylinder wall, but. And then as we come up, we're getting about 1/1000th. See if we can kind of go around to the other side and get the same spot. So 1/1000th. That's what I'm getting. And I think I can live with 1/1000th. Unfortunately, SAYLOR BEALL does not give the specifications for that cylinder. It's a 4 1/8 inch piston, so figure a thousandth over that. I don't think that's going to affect the compressor much, and especially with new rings. And we'll check our ring end gap once we get those, to that point. But I think I'm going to go ahead and hone that off camera. So I've done the measurements 2 different ways. I've done it with bore dial gauge and with these telescoping gauges, and measured it with a caliper. I get the same results both times, getting about 1 to 2 thousandths over. I have no idea what the spec is on this, but bore looks decent now, so I don't know if I want to push it too much more. And this is an air compressor, not an internal combustion engine, so I mean, we're still trying to hold compression, but when I run my hand across there, I really can't feel those anymore with my finger. So given the measurements, I think that it's probably safe to say we're going to have pretty good compression. And like I say, I don't know how big those new rings are. We'll test fit them in the bore. Generally, you're about 10 to 14 thousandths is what you want your end gap to be, so they don't come up over each other like this. Sorry about the fingers in the camera, but you don't want them to touch, and you don't want them to go over each other. They end up doing this and they'll break. So 10 thousandths is usually your minimum. But we've still got this small cylinder to hone, and it's pretty dark in that one. I don't know what I'm going to hone that with, maybe a brake hone, because it's really small. Get this gasket cleaned up and everything, get this degreased, and put some oil in this bore so it doesn't flash rust, because it's raining today, and that will flash rust in about 5 minutes. All right, we're making good progress cleaning up the gasket mating surfaces here, just using a little Scotch-Brite to get the remnants of the gaskets off, and the surface looks nice and flat, and I think we're in good shape here. Just have to clean everything, and then I'm going to hone this other cylinder. It has absolutely no ridge in the cylinder at the top from the piston rings, so I just want to give it enough crosshatch in there that the oil will stick to it. And then we're going to clean this bore up again. You can see there's a little bit of residual dirt and stuff in there, but I don't want to hone it anymore, take any more out. I think that's plenty. Got that cleaned up, and then I'll put some tape over here and I'll show you a neat little technique for masking this kind of stuff off, but not until I'm done. And I also need to clean all the oil and stuff off here so that the paint sticks. So I'll show you that when we get to that point. Okay, now I'm going to just kind of pull away and down. So I pull back and up. It could still pop free. Anywhere that gives you any resistance, just hammer it some more. Don't, like right there. I've got a problem area right here. Mash my fingy a little. Don't pull up, because it's just going to tend to pull away. You can do this with a regular hammer if you're gentle. I'll show you that real quick. Okay, we got it primed. It's just the first layer. Uni's crying in the background because she can't tie her shoes. I think this is more interesting than the compressor build. Anyway, back to the compressor at hand. I think that turned out pretty good, even though it's a little cool in here. I tried to just get even coverage, and then we'll try and get a heater in here after I get back from the gym and warm that up a little bit so it can cure properly.